Hi, I'm Brian Cargi Rodolfo. Today, let's talk about a little slice of communications, which is an FM transmitter. A transmitter is an electronic device which, with support of antenna, propagates an electromagnetic signal such as radio, television, or telecommunications. The world has entered an era known as information age, when electronic communication system influence most of the human activities. This electronic communication system consists of three major parts: the receiver, the channel, and the source, which is the transmitter. In frequency modulation, a FM transmitter, it consists of microphone, modulator, oscillator, radio frequency, and amplifier and transmitting antenna. There are two frequencies in FM signals. One is the carrier frequency, and the other is the audio frequency. The audio frequency modulates the carrier frequency. The frequency modulation FM signal is obtained by deferring the carrier frequency by allowing the audio frequency, where a microphone is used for converting the information to be transmitted into an electrical signal. RF amplifier is used for converting parts of transmitted waves. An oscillator is amplifier which provides its own input signal that is derived from the output signal and to generate the radio frequency RF carrier waves. And modulator is used for combining the information containing signal with the radio frequency and carrier waves. And transmitting antenna is used for the launching of the radio waves into the airspace. FM is the one of the primitive yet effective means of wireless communication, which is still used in several parts of the world. That's why I made a video in a simple mini FM transmitter circuit that covers a range of about 25-50 meters. The signal flow in a FM transmitter typically follow a specific sequence of stages. Let's understand it one by one. A microphone. An audio input. The microphone captures sound waves and converts them into electrical signals, representing the audio information you want to transmit. Modulation stage. The audio signal from the microphone undergoes modulation. This modulation process changes the frequency of the carrier waves in proportion to the amplitude variation of the audio signals. However, in many FM transmitter, the carrier waves is not generated at this stage. That's why we have a crystal oscillator, carrier waves. The stable carrier waves is generated separately. These carrier waves serve as an unmodulated phase frequency onto which the audio signal will be modulated. It provides a precise reference frequency for the FM transmitter. Next step is combining modulated signal with carrier. The modulated audio signal and the carrier wave from the crystal oscillator are combined. This process involves adding the modulated audio signal to the carrier waves, resulting in modulated RF signal. And then, the signal is amplified and filtered, transistor and capacitor. The modulated RF signals then undergoes amplification and filtering stages. The RF power transistor amplifies the signal to the required power level for transmissions. And ceramic capacitors and other filtering components are used to filter out unwanted noise in the harmonics, ensuring that the transmitted signal is finally the antenna. The amplified modulated RF signal is transmitted through the antenna. The antenna converts the electrical signal into electromagnetic waves for the transmission through the air. In conclusion, the signal flow typically goes from the microphone to the modulation stage, then combines with the carrier waves generated by the crystal oscillator, and finally goes through the amplifications and filtering in transmission stage which the antenna propagates.